For a quick review of the homework that you come up, in this problem, we have to define f as the function of two angles. It is given in terms of the positive y-axis. So finding the components of f in terms of x and y will be relatively straightforward. Remember that cosine does not mean x and sine does not mean y. Given different orientations of angles, you might have to switch that up, so pay attention there. When defining the force component relative to this normal and tangential, however, it becomes a function of two angles. When this is the case, you will want to use the windmill problem or the windmill method if you're having trouble visualizing where they're going. For the sake of future more complex problems, I would suggest to you to practice the windmill problem on this homework problem. Even if you're able to visually analyze it, practice the windmill method on a simpler problem where the angles are standalone. In this problem, we are looking for unknowns given the addition equation. Focus on this phrasing here, the net effect of the two cables, and we can define that as R, is down roots. So what we're given is an unknown magnitude and a defined unit vector. So this is only one unknown. But in this net equation, so T AB plus T AC, there's X and Y components. So we can actually deal with a second unknown. And in this problem, the tension T of AC is unknown. The magnitude of AC is unknown, but we do know that the direction of these forces, the tension in the cables, are going along the cables. So for the AB, this is the unit vector B with respect to A. And for AC, this is the unit vector C with respect to A. You will want to calculate these triangles to get their unit vectors. Notice that you are not given angles. I suggest that you never calculate an angle and instead use this R over R equation where you divide the vector by its magnitude to get a unit vector. And then that unit vector will give you the components needed to break this equation into two parts and solve for those two unknowns.